Hello everybody. Today we will start a new topic, probability. So today is our first class to this topic, probability 1. So first let us understand what is we called as random experiment. So random experiment is such that you will know the outcomes of that random experiment. Okay, so outcomes you will know. Okay, uh, also let's say there will be more than one outcomes for a random experiment, so more than one outcome. Okay, and it is not possible to predict the outcome in advance. All right, so not possible to predict the outcome in advance. Okay, so let's take an example. Let's say you want to toss a coin. So this is a random experiment, right? Because what will be the outcomes of a tossing a coin? It will be either tail or it will be head. So it has, like, you see, all the three criterias are met. When you are tossing a coin, you know what will be the outcomes. You know this can be either tail or head, nothing more than that. So the outcomes are known. It is like more than one outcome, right? It's not just you will toss a coin and only there is only tail will fall or only head will come as the outcome, right? So it is like more than one outcome, and it is not possible to predict in a fair trial with 50% probability of tails and 50% chances of heads. It is not possible to predict what will be the outcome in advance. Okay, this can be like one example. Again, one other example, that if you, let's say you rolling a dice, this can be a random experiment, right? So it will be, what will be the outcomes? It can be one, or it can be two, it can be three, it can be four, or five, or six, right? These are the outcomes of rolling a dice, right? So you see, all the three conditions will be met. You know what the outcomes will be. It is more than one outcome, and it is not possible to predict the outcome in advance. Okay, so this is called a random experiment. So this is one of the terms you need to know. Like, it's not like you have to know the definition or anything like that, but you have to understand what is a random experiment. So random experiment is anything which where the outcomes will be known, and you cannot predict the outcomes in advance, and there is more than one outcome. So you need to know in general. You get to have a feel of what is random experiment. Okay, now another very important term which is in association with random experiment, which is called sample space. I am doing it in this page only. Well, I just want to explain you what is a sample space here, because I have already gave the example in this sheet. So sample space is collection of all outcomes of a random space. So what is sample space? Collection of all outcomes of a random experiment. So it's like collection of all the outcomes. So let's say when you toss a coin, what are the outcomes? One outcome is tail, one outcome is head. So for this random experiment, tossing a coin, for this experiment, the sample space will be tail or head. These are the sample space, like it's tail and head. So this is a sample space for this random experiment. So for the random experiment, rolling a dice, what is the collection of all the outcomes? It is one or two or three or four or five or six. So what is our sample space in this scenario? It's one, two, three, four, five, comma six. So this is the sample space for this random experiment, rolling a dice. Okay, so I hope this is clear to you guys. Let's move on to the next topic. So let's take an example. Let's say a random experiment. Two coins are tossed. Just to illustrate what is sample space, what is a random experiment, what are the outcomes. So just to illustrate that point, I am doing another giving another example like random experiment. Two coins are tossed. So what will be the outcomes? Like let's say two coins are tossed. What can be the outcomes? The outcomes can be one can be tail, the other time it can be head, or else the outcome can be tail, or the next coin also it's tail, or maybe the first time it's head and the next time it's tail, or the first time it's tail and the next time also it's head. These can be the outcomes, right? These are the individual outcomes of this random experiment. Two coins are tossed. But what will be the sample space then? As I said in the previous case, sample space is always the collection of all the outcomes of a random experiment. So these individuals are the outcomes. So what will be the sample space? It is like tail head, tail tail, h head tail, and head head. So this entire set is the sample space. Okay. I hope this is clear to you guys. It's just another example. Similarly, one quick other example, which is often you will find it to illustrate this concept. Let's say a random experiment, because this is important, right? What is random experiment? What is outcomes? What is sample space? Next will come what is event. Okay, these are like the building blocks of probability. These are simple things, but it should be taken care in the initial stages itself. Okay, so that's why this is probability one. This consists of all the basic things, fundamentals. So let's say a pair of dice rolled together. Okay, so what will be the sample space? I'm this time not writing the outcomes individually because you can understand, right? From here, a pair of dice rolled together. So what can be one of the outcomes? One one. What can be the other the outcomes? One two, right? This can be the, I'm just writing here one or two of the outcomes of this experiment. A pair of dice rolled together. So one outcome can be one one, right? Again, another outcome can be 1 2, like the first dice is 1 and the second dice is 2. Another outcome can be 1 3, another outcome can be 5 1, right? These are all the outcomes. But what is the sample space? Sample space is a collection of all the outcomes. So this should be a big set, the set where all the outcomes are registered. That set is referred to as a sample space, the collection of all the outcomes in a random experiment. Okay, basically like the universal set. If we terms of in terms of set theory, if we go into that sort of definition, so it's like 1 1, 1 2, 1 3, 1 6, right? 1 4 1 5 1 6, again 2 1, 2 2, 2 3, like this it will go up till 2 6, like this it's 3 1 up till 3 6, similarly 4 1, 4 6 up go will go up till 4 6, then 5 1 all the way till 5 6, and then 6 1 all the way till 6 6. Okay, so how many, it's like how what's the total number of outcomes? You see this is like 6 here, 1 2 3 4 5 6, and 6 here, 1 2 3 4 5 6. So 6 rows, 6 columns. So what's the total number? 6 times 6 equals, oh, it's I'm not able to write here. Okay, sorry. Okay, so n sample space means what is the total number? It's 6 times 6 equals 36. Okay, so this is the, I think this is you guys, it's now more clear what is a random experiment, what is a sample space, what is outcomes, right? So set of the all the outcomes will be the sample space, and random experiments is such that what is random experiment, you will not know what the outcomes will be. Okay, more than one outcomes, and it's not possible to predict the possible outcomes. Okay, and you know the outcomes. The outcomes are known, right? In all the scenarios, we knew what are the outcomes. Okay. Now let's move on to the next topic. Now we will go. So right now we know what is random experiment. We know what is outcomes. We know what is sample space. Now we will go. What is an event? Okay. So event is a subset of a sample space. So event is a sample of a event is a subset of a sample space. Okay, let's take a quick example. Similar example that we used for when random experiment. I'm just writing it as I. Two coins tossed. Okay, two coins tossed. What was the sample space of two coins tossed? All the outcomes should be under the sample space, right? So it can be tail tail, it can be tail head, it can be head tail, it can be head head. So all the possible outcomes comes under sample space. Now let's say a event, somebody asks you what are the outcomes when there is only one head. What are those set of outcomes when we have only one head? That will fall under what we call as event because it is a subset of the sample space. So one head, what it will be, it is like tail head satisfies that criteria, head tail satisfies that criteria, and that's it, right? So again, let's say event, this is event number one, and then say there can be another event which can be number of heads is at most one. Number of heads is at most one. Okay, at most one, like let's say this is at least once. So number of heads can be like at least one number of heads we need to have from the sample space. Okay, so you see tail head consists of one head at least, head tail consists of one head at least, and two heads also consist of one head at least. So we have like this three outcomes fall under the this event, the second event. Number of heads is at least one. Okay, so I guess now these four definitions are clear. What is a random experiment? What are outcomes? What is a sample space? And what is an event? Okay, so just a quick way. So event is a subset of the sample space. Sample space is like the universal set, consists of everything, right? Outcomes, I mean individual outcomes of the sample space we are getting, and random experiment is such an experiment where all the outcomes are known beforehand, but you cannot say which outcome it will fall, right? It will come which outcome, so you cannot say that. So all have equal likelihood. Okay, so now we will go into the our event like probability, this topic, probability. So probability is equal to, let's say we want to find probability of an event A. So that will be small n by capital N. Okay. So what is small n? Small n is outcomes that are in favor of event A. This event A. Okay. So this is called the classical definition of probability. Okay. This is classical definition of probability. Okay. So n is outcomes that are in favor of event A, and capital N is the total number of equally likely outcomes. So this is like the total number of outcomes, and this is the favorable number of favorable outcomes for that event A. Okay. So basically, whatever the number of outcomes in the sample space is n, and in most scenarios, and small n is the outcomes that are in favor of the event A, right? The reason I said most scenario is because if it's like, let's say, like this is a universal set, and you have an event A here, which this is the event A. Here the inside that I'm doing it in a Venn diagram. N number of events are there. Okay, possible outcomes, not event. N number of possible outcomes that this event A has, and the total number of outcomes is n, right? And this is a sample space, entire sample space. Then obviously P of A is equal to n times capital N, which is a sample space, number of events, a number of outcomes in the sample space, right? But there can be some other scenarios which we will learn in the uh, later in the probability 2, which is called conditional probability. Okay, so let's not go there, but n is a total number of equally likely outcomes, and small n is the outcomes that are in favor of event A. Okay, so okay, so we will go in detail in of condition probability based theorem, those in the probability too. Okay, so right now we are only dealing with the basics. So n, the denominator will be the total number of events, and small n will be like if it's a single probability, like single event is happening A, then this A, the total number of events, total number of outcomes will be the sample space, right? The total number of outcomes. So keep it simple at this moment. Total number of outcomes is in the sample space, and n, small n, will be outcomes that are in favor of this event A. Okay. So keep it simple for this moment. Okay. So let's take an example. We already discussed this example before. Let's say the random experiment. What we are performing this time is rolling a dice. Okay. So you guys can easily understand, if we roll a dice, what will be the sample space. Please pause the video and answer this question. Okay, I hope you pause this video and you know what will be the sample space of rolling a dice. We already did it before also. 1, 2, 3, 4, 5, 6. This is the sample space. Okay, let's say we are describing an event A. Event A as an odd number appears. So if this is the event, what will be the outcomes for this event? An odd number of appears from the sample space 1, 2, 3, 4, 5, 6. So when we roll a dice, and if an odd number of appears, that registers under event A, so it will be 1, 3, 5. And let's say we have an event B where we say an even number appears. So what will be the outcomes uh, for that event? It will be 2, 4, 6, right? The outcomes for event V is 2, 4, 6, right? Now you see, event A is the subset of the sample space, which is 1, 3, 5. Event B is 2, 4, 6, right? Now you see here, A intersection B, is there any common terms between this event A and event B? It's 1, 3, 5 and 2, 4, 6, right? There is no common terms, right? So this will be 8 intersection B will be 5. So this means A and B never occur simultaneously, right? Like, because A is completely different. It's 1, 3, 5 are the outcomes of A, 2, 4, 6 is outcomes of B, A intersection B is 5. So this A and B never occurs together. And we get that A intersection B as 5, right? So means A and B never occurs simultaneously. So this cases we call it as mutually exclusive events. So you see here event A and B are mutually exclusive events. So in scenarios when where A intersection B equals phi, then we will get mutually exclusive events. Okay, this is also important concept, and it is very, it's coming from common sense, right? If when they will be mutually exclusive when A intersection B, when there is no common between A intersection B, right? When A intersection B is phi, then we will refer those two events as mutually exclusive events. Okay, now let's move on. Let's take one scenario here. Let's say this is a universal set which we have, that is a sample space. Okay, sample space S. Here this is one event, so the outcomes of one event A will fall under this Venn diagram, and this way here B is another event B. Okay, so the number of outcomes under A is n1, and for B it's n2, and whatever is the intersection position, let's say it's P, and total number of outcomes, let's say, is n for the sample space. Okay, so now you see number of outcomes for A union B. What will be the number of outcomes for A union B? It will be number of outcomes for A plus number of outcomes for B minus number of outcomes for A intersection B, right? So it's like number of outcomes for A and A union B, this entire region. What will be the number of outcomes? It will be n1, and n2 p is added two times, so we are subtracting 1p here, because when we are saying n1 p is included, when we are saying plus n2 again p is included, right? But we only need 1p, we don't need 2p, so we are subtracting 1p from here. So basically number, this will be equals number of events in A is n1 plus n2 minus p. Okay, now what will be the probability of this event to occur A union B? What will be this probability? So probability is, we already discussed the last sheet we were discussing. The probability is number of outcomes that are in favor of a certain event divided by total number of outcomes, right? So A union B, number of events are which are in favor of A union B, n1 plus n2 minus p. This is the number of events, number of outcomes, sorry. So A union B is itself an event, right? So number of outcomes that are in favor of this event A union B is n1 plus n2 minus p. What are the total number of outcomes that is in the sample space is n. So we will divide by n, right? This is from the classical definition of probability, right? So from here we will get n1 by n plus n2 by n minus p by n, right? So you see n1 by n, this is this one, n1 a by the entire set n, right? So this is probability of A, right? So probability of the event A means the number of outcomes in favor of event A, which is n1, I wrote it, the number of outcomes, divided by total number of outcomes, which is n, right? N is in the sample, n is the sample space, number of outcomes in the sample space, right? Basically. So that is n. So n2 by n is probability of B, and probability, and p divided by n is probability of A intersection B, right? So this formula is also, it's not like a formula, but still you have to remember it. It's PA union B equals PA plus PB, probability of A plus probability of B minus probability of A intersection B. Okay. Now let's say we have a condition. Let me draw it here only if I have space. I think, yeah, I have it. I think I can draw it. Let's say we have a scenario like this where this is the event A, and this is event B. Okay, this is event A, this is event B, this is sample space S. Okay, so what is the probability of A intersection B here? You see, there is no intersection between A and B, right? You cannot, there is no intersection. Here they had an intersection, that's why we wrote P by N was the probability of A intersection B, right? But here probability of A intersection B, there is no intersection. So we will write PA union B equals PA plus PB, since PA intersection B equals 0, right? 0 or phi, whatever, null set basically. So, no, this will be 0, sorry. When we wrote phi, you see the previous sheet, this number of outcomes between A and B can be written as phi, but the probability has to be written as 0, right? There is a null set. There is no number of uh, outcomes which A and B both happens together. There is no such outcomes. But what will be then the probability of A and B happening together? It's 0, because probability is always 0 and 1, right? So from here, so we can write for PA union B equals PA plus PB. This is also the condition for, as we discussed before, mutually exclusive events. For mutually exclusive events. Okay. So for mutually exclusive events, basically P A intersection B will, this term will be 0. So probability of A union B will be PA plus PB. You don't have to memorize all these things. You can get it from common sense only. This you might memorize it, but this also we will get. We can just find A and B. We can understand it's PA plus PB minus this intersection part, right? Because this is added twice. So even this you don't need to memorize, but still, if you want to memorize something, this is okay. You can just kind of memorize, but still need to understand it. Then you can apply it on all scenarios. Let's say for mutually exclusive scenario, where there will be no intersection between A and B, you can just say PA union B equal to PA plus PB. Since the intersection is 0, so PA union B equal to PA plus PB. Okay. Now, so we right now know. Oh, sorry. Okay. Okay. Sorry. So up till now we know what is a random experiment. We know what is our random experiment. Then we covered outcomes, right? Then we covered sample space. What are the sample space? And we covered events, right? What are events? And then mutually exclusive events. Okay. So now we will do is exhaustive events. Okay. Let's say E1, E2, E3, all the way till En are exhaustive events. Let's say these are all exhaustive events. Then by this we mean is the entire sample space S that we discussed before, which consists of all the outcomes. All the outcomes should be under the sample space S. This has to be equal to all the union of the exhaustive events. A1 union A2 union E3 all the way till union En should be equal to the sample space. Okay. So that means probability of E1 plus probability of E2, which is very obvious, right? Probability of a sample space is equals 1 always, right? So probability of En should be equal to 1. Very obvious term I'm writing here. Because if this is a sample space, let's say this is event A, this is event B, that's fine. So these have some probability. But if somebody says, what is the probability of this sample space? Entire sample space. So probability of the sample space, what is the total, and the total number of outcomes was n. So but now when you need to find probability of the sample space in favor, number of outcomes in favorable also is n, divided by total number is also n, right? So equals 1. I'm writing a very obvious thing, since it's a probability in one class. I don't want anybody to miss something. I want everybody to be on the same page, going with the flow. Okay, so here, since S equals E1 union E2 union E3 up till union En, so when we do probability E1 plus E2 plus up till En, this has to be equal to 1, right? Since probability of the sample space equals 1. Okay, now one more thing we will do, then we will call it a day. Let's say this is sample space S and this is event A. Okay, if this is sample space, entire thing is sample spaces, and this is event A, then we call A dash or A bar as complementary event. Okay, by complementary event, what we mean? So if this is A, then sorry, then the same sample space S and the same event A, let's say, just consider both are identical. Okay, so this part now will be A complementary. This is A, but the other whatever except A, everything except A will be A complementary in the sample space. Okay, so you see A and if this is A and the rest everything is A complementary, then we can understand A intersection A complementary, the number of outcomes which are between A and A complementary, which is A and A complementary, the number of outcomes will be 5, null set. There is no common outcomes which is between A and A complementary, right? So these there are definitions you need to remember, because in some problems they directly ask you in boards especially. Let's say in odds in favor of A, they ask you find what are odds in favor of A. But if you don't even know the definition, how can you do odds in favor of A? So odds in favor of A is as PA divided by PA complementary. Okay, and odds against A is the reciprocal of that. P A complementary divided by PA. Okay, so we find what is odds in favor of A and what is odds against A. So from here, as I said, probability of a sample space is always one, as I proved it also, right? N by n in the last sheet. So here we will do, what we see is probability of A and probability of A complement is always equals to 1, right? From very basic sense. If the probability of A and A complement covers the entire sample space, right? So I think I will just summarize a little bit what we learned today. Very basic, simple stuff. I just want to keep the foundation correct. So we learned what is a random experiment. We discussed that. Then we discussed what are outcomes, right? Then we discussed what is a sample space. Sample space is the entire set of outcomes is the sample space. Then we saw what is event. Event is an event such that the outcomes will be a subset of the sample space. Then we discussed mutually exclusive events, right? Discuss mutually exclusive events. This will be a intersection B equals phi n. The number of A intersection B equals phi. Then we did mutually exhaustive events today, right? It will be PA plus PB all the way up till P, whatever the, let's say E or something. This has to be equals to 1, right? For mutually exhaustive. If I have written a PEN, okay, I did it like that before. So whatever. So it's PA1, A2, all the way till AN. If these events are exhaustive, then all the probability should be equals to 1. And at the end, also we learned in the between P, what is PA union B. We write P union B is PA plus PB minus PA intersection B, right? And last we learned what is complementary events. So next sessions we will do what is called as conditional probability. Okay, conditional probability, Bayes theorem, independent events, and some problems related to all these concepts. Okay, and some other things if we are left we will see. I will just check and then we will cover this in the next probability too. Okay, so till then, hope you guys have a great day. I hope you enjoyed this video. Please also, if you find this useful, please like and subscribe to our channel. Also, please share it with your friends. Thank you so much. Bye.